from the smallest to the giants. The Earth is full of different animals. We now know about 1.5 million species of animals that live on Earth in whatever size and shape you can imagine. Accurate knowledge of each is so necessary to biologists that a whole branch of taxonomy separates living things based on their important traits. It is interesting to note that we have probably not yet discovered the 40 million species that inhabit the Earth. Invertebrates. About 2/3 of the animal species on Earth belong to a large group of invertebrates. From the subsets of this large group, we can mention all the animals in the branches of corals, mollusks, echinoderms, sponges, worms, and arthropods. In addition to having several similarly important traits, these animals all lack a spine. We all know several invertebrates, including worms, arthropods such as insects, crabs, and spiders, or mollusks such as snails. In contrast, many animals in this large group are so small or out of reach that we will never see them. Many of these groups live in the oceans and, unlike the insects that can be seen everywhere on the planet, hide in the dark depths of the oceans. Vertebrate. Many of the animals we know best and have dealt with the most, including our own, belong to this group. The main feature of these animals is having a spine or a set of vertebrae that are often located along the animal's trunk and contain the spinal cord. The spine forms the central part of the vertebrate internal skeleton that can move with the help of muscles. Depending on their environment, many vertebrates have different limbs, such as limbs, wings, or fins, which often act in pairs. These animals have complex sensory organs and large brains and form a group of the most evolved animals on Earth. Vertebrates are often divided into 5 categories: birds, mammals, reptiles, amphibians, and fish. Among these categories, mammals, birds, and a group of fish are warm-blooded. They can minimize the impact of external conditions by controlling their body temperature. Mollusks. Soft-bodied animals that often live in hard shells belong to this group. The nautilus you see in this picture is one of them. Echinoderm. They are a group of marine mammals that often have a body with a 5-radius symmetry. In many cases, the skin of these animals is covered with thorns or limestone rings. Birds. Animals with feathered and egg-laying bodies that use their beaks for hunting or feeding belong to this category. Their light skeleton, which has multiple air cavities, allows flight. Cnidaria. The mermaid, the sea anemone, and any other aquatic animal with multiple arms around its oral cavity belong to this branch. Mammals. This group of animals whose bodies are covered with fur or hair feeds their children breast milk. Reptiles. Animals such as snakes, lizards, crocodiles, and turtles, whose body surface is covered with dry and scaly skin, belong to this category. Most of them lay eggs. Amphibian. This category is for animals such as frogs and salamanders that spend part of their lives on land. But they always need aquatic environments for their offspring. Fishes. Aquatic animals that swim with their fleshy or prickly fins and often breathe with the help of their lungs make up this category. Evolution in animals. In nature, nothing can remain unchanged for long. Organisms begin to change over several generations to adapt to environmental conditions and live better lives. Those that fail to adapt to the environment will perish and become extinct over time. A process that involves slow changes in living things is called evolution. This process results from the unparalleled diversity in the various forms of life we see today. How does evolution work? We often expect the children of any living thing to be like their parents and display the same qualities they inherited from their parents. But we know that genetic information is not exactly copied, and sometimes we can see the emergence of new traits in later generations. If the new trait is positive, such as the color of the animal's body covering, which can lead to better camouflage, it will help the animal to live longer than its peers and thus have more children, who will also have this new positive trait. For example, stripes that run parallel to each other on the zebra's body are one of their positive features. Each zebra can easily identify its family members in the herd with the help of these strips, which are different in each family. Giant mammals. The massive devastation that can result from supervolcanic eruptions or meteorite impacts on Earth changes the environment around animals so rapidly and unpredictably that there is no chance of adaptation, and many species are in danger of extinction. This is what happens in every major extinction. After the Great Extinction that occurred on Earth 65 million years ago and led to the extinction of the dinosaurs, giant mammals evolved to replace the dinosaurs on Earth. Among these gigantic animals are 5.5-meter tall rhinos, giant sloths, large blue dogs, and armadillos several times larger than their modern-day relatives. The giant armadillo of Glyptodon, a distant relative of modern armadillos, lived on Earth from about 5 million to 10,000 years ago. Losers called Barapasaurus. Barapasaurus, like other sauropods, was one of the losers in the extinction that occurred on Earth about 65 million years ago. The heaviest and largest inhabitants of Earth's history have been members of this group of dinosaurs. Winners and losers of the Great Extinction. Many of us think that all dinosaurs became extinct millions of years ago. But in reality, this hypothesis is not entirely true, and the survivors of these prehistoric giants still live on Earth. They are the descendants of theropods that walked on two legs. Among them, we know better the Tyrannosaurus and the Velociraptor. Geologists say that about 160 million years ago, feathers grew on the body of several small theropods that probably helped keep them warm. Over time, these tiny dinosaurs learned to use their feathered hands to climb or fly. Eventually, evolution caused small theropods to become birds and survive the Great Extinction that occurred 65 million years ago. For example, by looking at vultures, we can see one of the winners of the evolutionary process. The wrinkled scalp and eyes that remind us of reptiles are all signs that birds are dinosaur survivors. It is interesting to note that 99.9% of the animal species that have ever lived on Earth have become extinct. It is interesting to note that the bodies of all animals are made up of cells that together form tissues such as muscles and bones or organs such as the brain, kidneys, and eyes. Although the arrangement of these tissues and organs is very different in different animals, we often see similarities in near and far relatives. It can be said that the arrangement of the limbs has consistently been chosen in the best possible way to be in perfect harmony with the unique way of life. Vertebrates and spine. Vertebrates have an internal skeleton comprising a combination of bone and cartilage. This skeletal structure protects the animal's body and internal organs. It provides a suitable framework for the connection of motor muscles. The brain is located inside the skull, and the spinal cord, a vital part of the central nervous system, is protected by interconnected vertebrae forming the spine. Awkward vertebrates. Most vertebrates use limbs such as limbs, fins, or wings to move. But snakes are an exception. Like the cobra you see in the picture, their skeleton consists only of the skull, spine, and ribs. The ribs of the reptiles and the abdomen can be spaced apart to allow enough space for a large prey to be swallowed. Natural armor. The hard skeleton covers the body of arthropods such as crabs, insects, millipedes, and spiders, which act just like a fish in armor and are precisely the size of each. This particular armor even covers the area around the arthropods' mouths and eyes. The exoskeleton of these animals is made of a light, flexible material called chitin, which is hardened and resistant to various minerals. This natural armor, which protects the arthropods' bodies well, will make it difficult for them to move and grow. Unlike vertebrates, whose internal skeleton grows with the animal, the external skeleton of arthropods is hard and unable to expand and grow. That is why this group of animals needs to dissect the exoskeleton and renew it to continue its growth. Some arthropods, such as this Ecuadorian velvety brown tarantula, are soft and vulnerable for several hours after peeling. In such cases, they are often hidden in a safe place so that the new and larger exoskeleton becomes as firm as the previous example. Invertebrates that lack an exoskeleton also protect their bodies in a variety of ways. Many creams maintain their body shape with the help of internal fluid pressure. Starfish and sea urchins protect it by building a layer of limestone under their skin. Several mollusks, like bivalve mollusks and wrinkled oysters, have a hard, calcareous shell that provides security. Other groups, such as squid and octopuses, often depend on the aquatic environment in which they live to maintain their body shape. Animals have many basic characteristics in common. They all grow, move, feed, and reproduce. To better interact with the world around them, they use different senses. They can communicate with each other at different levels. Differences begin where each animal uses its unique way of doing the above activities and exhibits a stunning variety of unique behaviors and lifestyles. For example, if the chameleon were not careful in aiming and lurking in silence, this playful hunter would always be hungry. Chameleons can hunt insects up to 1.5 times their body length. To do this, the animal's tongue comes out of its mouth faster than fighter planes. Having different senses is necessary to keep animals alive. These senses help each animal to find food and mates or to escape various dangers. Many animals, like humans, can see light rays or feel touch. In addition, many of them have a variety of chemical receptors in their bodies to sense the taste, smell, sound, and vibration of objects. Other animals have very different and unique senses. Consider, for example, migratory birds that find their way miles away using the Earth's magnetic field. Unlike us humans, bees can also see ultraviolet light. Many plants have ultraviolet patterns on their petals that are invisible to us. But these patterns can lead bees to pollen and nectar from flowers. Many nocturnal animals also have large eyes that help them collect the largest number of light rays in their eyes and see better. It is interesting to know that the eyes of a spectral nocturnal monkey are larger than the brain of this animal. Many animals live in ever-changing ecosystems and therefore need to move to find new food sources, new nests, and other animals that belong to their species. Even animals such as the barnacles, who spend their puberty at rest, are active in their youth. More mobile animals can be classified as walking, running, jumping, crawling on the ground, climbing heights, swimming, peaking, and flying. Movement requires energy. For this reason, the bodies of most animals are designed in such a way that due to their way of moving, they need the least possible energy to move. Animals use a variety of ways to communicate with each other, including sending visual, audio, and chemical messages. These messages are often simple. Take, for example, the trail of an animal that marks its territory or the howl that warns other group members. Other sounds can be heard in nature, which can belong to a mother looking for her child or show the anger of animals or their search for a mate. In addition, sending and receiving messages among animals such as wolves or bees that live in groups will make it easier for them to work and live in small or large communities. For example, the male peacock opens his colorful and beautiful umbrella to show the female peacocks that he is a strong and suitable mate. In addition, he tries to attract the attention of the opposite sex by waving his feathers. Or the wolves howl to find other members of the group or to tell rival groups to stay away from their territory. If there is no obstacle in the way, their howls will be heard up to 16 kilometers away.